Okay, this is number 2. On number 2, we're supposed to find the dimensions of a rectangle with a perimeter 100 feet whose area is as large as possible. All right, so first of all, I know my 2 equations. I have a perimeter of 100 feet, and then they've asked me, I want to find the largest area. So if I have a rectangle, okay, I'm just going to call the side X, the side Y. So I know that my perimeter is going to be 2x plus 2y equals 100. And the area equation would be x times y. I know that this is the part that I'm taking the derivative of because I want the maximum area. I can't take the derivative of something that has 2 variables, so I need to replace one of these. So I'm just going to solve for y on this. I have 2y equals 100 minus 2x. Divide by 2, and I have y equals 50 minus x. So I'm going to go over here, replace that y with 50 minus x. I'm going to simplify by distributing. So 50x minus x squared. So now since this is my area, I now am ready to take the derivative of that. So the derivative is 50 minus 2x. I'm going to set that equal to 0. Solving for x, I'm going to subtract 50. And then dividing by negative 2, I get x is 25. So if x is 25, I can figure out what y is by plugging it back into the here. Y is 50 minus x, so y is also 25. So the dimensions of this rectangle is 25 by 25, which just happens to be a square. All right, number 3. You're building a rectangular fence that uses the side of a house as one side and fence for the other 3 sides. So I'm going to say that this is the side of the house. All right, so I know I'm going to have a fence like this. If you have 80 feet of fencing available, what should the dimensions of the fenced-in yard be to yield the largest possible area? So again, I have the perimeter of this fence. So this side is going to be x, this side is x, this is y. So I know that 2x plus y, and it says I have 80 feet available, so this can equal 80 feet. Okay, and then I want the dimensions of the largest possible area. So the area of this is always my length times my width, or my base times my height. So my area is x times y. Again, I know that I'm finding the derivative of my area because that's what I want to find the largest or the maximum of. I can't find the derivative when I have 2 separate variables. So that's why they gave me this. So I'm going to solve this for y again. Y equals 80 minus 2x. I'm going to take this and plug it into this y. So I have x times 80 minus 2x. Distributing my x, I have 80x minus 2x squared. Now I'm going to find the derivative. So the derivative is 80 minus 4x squared. Set that equal to 0. So negative 4x squared equals negative 80. Dividing by 4, I get x squared equals 20. Here's my problem. I knew something was wrong. This is not x squared anymore. It's just 4x. So I'm going to fix that real quick. Okay, because 80, the derivative of 80x is 80. This is 4x. Okay. So x is equal to 20. So I know this part is 20. If I want to find out what y is, I have to plug it back into this equation. Y equals 80 minus 2 times 20. So 80 minus 40, y is 40. Okay, so the dimensions are 20 by 40 feet. Okay, number 4. What are the dimensions of the lightest open top right circular cylindrical can that will hold a volume of 1500 cubic centimeters? Okay, and if I give you this kind of problem on the test, I will give you the volume formula and the surface area formula. Surface area for an open top can, so I don't have that top circle, is going to be pi r squared plus 2 pi rh. And my volume for that can is pi r squared h. So anytime I want the dimensions of the lightest can, I have to find the derivative of my surface area. So the problem with this is I have variables of r and h. I can't have both. So that's why they gave us this. I know that my volume is 1500. So I can substitute 1500 in place of my v. And then I have to decide what I want to solve for. I'm going to solve for h. So divide by pi r squared. So h is equal to 1500 over pi r squared. So I'm going to take this and I'm going to plug it into this h. So now my surface area equals pi r squared plus 2 pi r times h, and h is 1500 over pi r squared. So before I find the derivative of that, I'm going to simplify that as much as I can. That's pi r squared. Do you see that this pi r will cancel with this pi and one of these r's? 2 times 1500 is 3000 over r. I need pi r squared. That's a plus sign in between there. So now I am ready to find the derivative of that. So the derivative, I'm just going to call this surface area prime, SA prime. Derivative of pi r squared is 2 pi r. When I find the derivative of 3000 over r, I actually have to bring that r up to the top. And it's going to be minus 3000 r to the negative 2. And I'm going to go ahead and bring that down to the bottom. So now I'm going to bring this over here. So the derivative is 2 pi r. I'm sorry, I'm going to go ahead and set that derivative equal to 0. So 0 equals 2 pi r minus 3000 over r squared. I'm going to multiply everything by r squared. So I get 0 equals 2 pi r cubed minus 3000. Solving for r, I have 3000 equals 2 pi r cubed. Divide by 2 pi, and I get 3000 over 2 pi, which is really 1500 over pi equals r cubed. So r is going to be this cubed root of 1500 over pi. That's my radius. The question says find the dimensions. So I know my radius is the cubed root of that. To find my height, remember up here we solved for h. So I'm going to plug my r into that. So 1500 over pi, and I have to take this 1500 over pi and square it. And that's what is equal to h. I think when you simplify that, they actually equal the exact same number. Okay, if I were to put this in my calculator, it's 7.815. If I were to put this in my calculator, that whole thing, it's the same thing, 7.815, and we are in centimeters. Okay, so here's my height. There's my radius. Okay, I'm going to do the next 5 through 10 on the next video.